Let's now look at sigmoid linear unit, and as you can see here in the docs, it is also called as swish, swish activation function. Here are the references, and if you look at this reference right here, we can see that this magenta line, that's the SILU, sigmoid linear units, as compared to the ReLU, when the values are negative, that is values are below 0, uh, as we have seen earlier, these tend to become smaller and closer to 0, but they still retain the negative sign, so the negative values become smaller. And if we try and run this here in this code, we can see that if the values are uh, -4 or -3, they come closer to 0, but then they're still negative. The values are much farther out on the negative side. They are 0, and if the values are on the positive side, they uh, they have their sort of larger values still exist there. But if the values are in the range that are closer to 0, as we can see right here, these values, let's say values up to 1, 2, and 3, then those uh, tend to become a little smaller than what they are. For example, instead of 2, we have value of 1.76. Instead of 1, we have value of 0.73. And we can calculate these values by multiplying the value here denoted by x with the sigmoid value. So sigmoid value we can calculate by 1 divided by 1 plus exponential to exponential to minus x. So we exponentiate minus x, and we can look at the formula right here, same formula for sigmoid, and when we run this, we get a value of 1.76, which is what we have here. If we change this value and make it a large negative value, this would approach 0. So pretty small value, close to 0. And if we have this as positive number, the value is as it was 1, 2, 3. So that's how the sigmoid linear unit or swish linear unit works. If you have any questions, comments, or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.